Today I'm presenting our project, the AI-powered DPC recommendation system. It's a web-based platform that helps users to improve energy efficiency of their buildings without needing a professional assessor. And we are achieving this with instead of relying on slow manual inspections, users can enter building details themselves. And the system then analyzes this data using a combination of mathematical logic and AI to generate personalized and energy-saving recommendations. And our goal is to make energy assessment faster, more accurate, and more accessible. And now let's talk about agenda. Today I'm gonna shortly explain this problem statement, technical background, and we will make a demo of our application. Um, Buildings are one of the biggest energy consumers in the world. They account for more than a third of um, global energy use and are a major source of carbon dioxide emissions. To address this, countries use energy performance certificates, which rate buildings and offer advice. But the current process is so slow, costly, and not flexible. It requires someone to visit the building in person, and the suggestions given are usually too general to be useful. Because of these issues, it's hard to scale the system or apply it in bulk. And our goal is to avoid these issues. And let's talk about technical background briefly. First, we use a method to evaluate the building's energy efficiency. We analyze the data set of 40 million EPCs from the United Kingdom to find patterns, then group these buildings by type and whether they have access to main gas. And let's talk about now the backend structure. Our backend is a Spring Boot structure. We developed a JWT based authentication, and our database is MySQL here. And for rack side, it is there are some PDF files about specific things like recommendations of energy savings about buildings, and we chunked these PDFs first and converted to embeddings and sent them all to Pinecone, which is a vector database. And for all coming questions from users embedded is the same way we did here, and goes into Pinecone to make semantic search. And there's a retrieved document created, and this document is sent to LLM, which is OpenAI here, and OpenAI makes an answer, and this answer both returns user and saved in chat history in MongoDB. And now let's talk about the demo here. Firstly, we are logging into the system. And there are some dashboards here, and we see that we are totally buildings of 8, and our current average rating is D, which is average, and we can increase this rating up to B, which is very good here. And out of 8 buildings, the most frequently recommended one is low energy lighting and multi-glazing. And we can here analyze building. We can see the analyze page here, and even we can click chat and make some conversations about the LLM. And for example, if I say what can be done for my building and select a house, and this house firstly is analyzed through our mathematical calculations, and then it is returned that based on the analyzed results like that. And this kind of response is coming from the LLM and our personalized structure. And here we can see our buildings and information page, and that was our application.